In the first video on solving quadratic equations, I showed you how to solve them by factoring. In this video, we will do several example problems so that you can perfect the skill. Here I have the quadratic equation x squared plus 5x subtract 24 is equal to 0. I'd like you to follow the 8 steps in order to solve this. I'd like you to turn this off and start back up again when you have finished, and then you can watch me as I go through those 8 steps. Okay, hopefully you've had a chance to go through and do this problem. This is how I would go through and do this particular problem following the 8 steps. Step number 1 says be sure that one side's equal to 0, and it already is. Step number 2 says to find factors by setting up those 2 sets of parentheses. So I'm going to set up these 2 sets of parentheses. And step number 3, determine what the first 2 terms have to be. Once again, an x and an x, because x times x is equal to that x squared. Step number 4, determine what the operation signs must be. In this particular quadratic equation, once again, this is a subtraction, which means that these 2 signs have to be different because I have to get a subtraction. I have to get a negative number. So I know that one of them has to be addition. I know the other one has to be subtraction. Then it says in step number 5, determine possible answers for the last 2 terms. I know when I multiply these last 2 terms together, I have to get 24. So in order to get 24, I could have 24 and 1, or I could have 2 and 12, or I could have 3 and 8, I could have 4 and 6. Well, I know that I have to end up with a 5. So I'm taking a look at all these sets of numbers right here, and I'm trying to take a look at them. Which sets of those can I add or subtract to get 5? And obviously it is the 3 and the 8. So I know I'm going to need a 3 and an 8. Now I just have to determine, does the 8 go with the addition or does the 8 go with the subtraction? Since it is a plus 5, since it is add 5, I'm going to put the bigger number with the addition. So that would be x plus 8, and then that would be x subtract 3. Now that I have done that, I'm just going to check very quickly just to make sure that works. I'm going to rewrite what I think it is, x plus 8 times x minus 3, and apply the FOIL method. X times x is equal to x squared. Then the outer, subtract 3x. Then the inner, add 8x. And then the last, I get subtract 24. And certainly when I go through and combine the negative 3x plus 8x, I do get 5x. So it does work. If I do the FOIL method, I do get my quadratic expression, or that part of the equation, x squared plus 5x subtract 24. So now I am into step number 7, and I'm going to set each of these equal to 0. So x plus 8 has to equal 0, which means x is equal to negative 8. Or x minus 3 is equal to 0, which means x is equal to 3. So those are the 2 different possible answers. And once again, I could put those 2 different possible answers into this original quadratic equation, make sure that it does equal 0, and I will leave that to you. It certainly will work when you go through and do that. Here's another example for you to practice. So once again, I'd like you to turn off the video and go through and do the problem, and then turn it back on again when you are ready. Okay, as I go through and do this problem, once again, the very first thing is to be sure that one side's equal to 0, and I see that I do not have the right-hand side equal to 0. If I add 9 to both of those sides, I'm then going to end up with x squared subtract 6x plus 9 is equal to 0, so now I can run through and do that. Next thing I need to do is find factors for the quadratic, so I'm going to set up my parentheses. And once again, I know x times x is going to be giving me the x squared. Now I need to go through and figure out what signs I need in here. And since this is an addition, I know that those 2 signs have to be the same, because when I multiply 2 positives or 2 negatives together, I'm going to get a positive. Since this is a subtraction, I know that they both have to be negatives. So I have x subtract and x subtract. Now I need to go through and I need to figure out what terms I'm going to want to use. And the numbers I could multiply together to get 9 are 1 and 9, 3 and 3. And I want something that's going to give me this 6 when I add or subtract. So it's obviously going to need to be the 3 and the 3. So I'm going to put the 3 and the 3 in there. The next thing says to check it by the FOIL method. I'm not going to do that right now. It is going to work just for the sake of time. And now I need to set each factor equal to 0. So if I set this equal to 0, x minus 3 is equal to 0, so x is equal to 3. This is exactly the same thing. X minus 3 is equal to 0, so x is equal to 3. Remember at one point in the earlier video I had mentioned to you that because this is a 2 right here, that means that I could have up to 2 different answers. I can actually have no answers that would work. I could have one answer that works, as in this particular case, or I could have 2 different answers. In this particular case, I only have one answer, and that answer is x is equal to 3. Here's an example of a quadratic equation that does not have any answers whatsoever. If I go through and try to solve this particular one, it is going to be difficult to figure this out by factoring, but I am going to go through these same steps. I know it would be an x and an x. Since this is an addition sign right here, I know that the signs have to be the same, and since that's subtraction, they would both have to be a subtraction. And now I need to go through and I need to figure out what numbers I can multiply together to get 9. It would be 9 and 1, or 3 and 3. Well, neither one of these solutions, when I add or subtract them, is going to give me that 5. Now, it certainly would be possible to have some fractions there, but even putting some fractions in would not work for this. Solving by factoring, it is not very easy to determine that there are no possible solutions whatsoever. In the next video, I'll talk about another method that will work, that will tell you right away that there are no solutions. But in this particular case, there are no solutions for this particular quadratic equation. So I would just say that it is not possible for this particular quadratic equation. Up to this particular point, you may have noticed that all the quadratic equations that we have dealt with start off with x squared. Well, they certainly all do not have to start off with x squared. I could have a number in front of the x squared, for instance, 4x squared. My subtract 8x, subtract 5 is equal to 0. To do this particular problem, I would still do it exactly the same way if I was going to choose to do it by factoring. I'm going to set up my parentheses, and then I need to determine, well, what times what would give me 4x squared. The difficulty when I have something other than 1 in front of the x squared is that this could be a 2x times a 2x, or this could be a 4x and an x, which then increases the possibilities of all sorts of different answers. This type of problem can certainly be solved by factoring if you want to play with it a little bit. However, there is another method known as using the quadratic formula that probably would work a little bit better if you have a number in front of the x squared that is something other than a 1. For this particular problem, I am going to show you that this can be solved by factoring, and I'm just going to do it because I know what the answer is. It would be a 2x and a 2x. It would be 2x add 1, 2x subtract 5. It would work, and I would set both of these equal to 0. 2x plus 1 is equal to 0, which means 2x is equal to negative 1, and x is equal to negative 1/2. That would be one possibility. And if I set 2x minus 5 equal to 0, I would get 2x is equal to 5, which means x would be equal to 5/2. Both of these do work, and you can certainly solve this by factoring, as I have done here. However, as I say, there's probably a better way to go through and solve these. And once again, I could go through and check both of these answers, and once again, that does get a little bit more complicated because now I'm dealing with fractions, but it would work. In the next video, I will talk about how to go through and solve something like this in a different manner.